Hi, my name is Alexander Tetjaw, and today I'm going to talk about design and make with artificial intelligence, augmented reality, and robotics. I'm a researcher at MIT investigating ways we can collaborate with machines to create physical objects all around us. From toys, sculptures, furniture, to buildings. My fascination with making things started while I was studying architecture right here at Cornell. I became interested in the idea of turning concepts into reality through design. There are actually many ways we can make physical things all around us. Some are made by hand, some are helped with a computer, and some are manufactured by a machine. The way that we use these tools and technology to make physical things all around us made me further interested in studying architecture and computer science at MIT. Along the way, I noticed something very important. Making physical objects isn't always so accessible. It takes a significant amount of time, labor, and expertise to bring something into real life. But what if I told you that there is a way to bring physical objects by simply speaking objects into existence, where you can make objects on demand with the help of AI and robotics? Imagine a scenario where you say, I want a chair, and within 5 minutes, a physical chair is made just for you. And this is what we can do right now, where you can say,
assemble me a table with one leg.
The system thinks for a while and assemble exactly what you asked for, a table with one leg.
A shelf with 2 tiers.
The letter T.
I want a simple stool.
The robot can assemble it all, from a table, shelf, to a stool. You can go from speech to reality in a matter of minutes. The way that the system works is you start with speech, that gets converted into text, and then an AI-generated object. This AI-generated object is then turned into assembly components and robotic toolpath. The reason why this is important is because access. Not everyone knows how to use a 3D modeling software or use a robotic programming tool. And the next part is time. A robot can assemble you an object that you need within minutes. And lastly, this process creates minimal waste. With the help of generative AI and robotic assembly, you can get objects assembled and disassembled to fit your changing needs over and over again until you get what you need. All of this sounds exciting, right? It's like the ChatGPT of physical objects. You say what you want, and the robot builds it for you. Ultimately, the goal of this project is to democratize access to physical making by going to speech to reality with the help of AI and robotics. But maybe not all objects should be made by a robot. What if you want to do something for fun? For example, assemble a Lego or solve some puzzles. How can a machine still help you in this process? And this is what we explore with this project called AR/AI Assembly, Augmented Reality and Artificial Intelligence for Assisted Assembly. Instead of replacing the hands-on making experience, AR/AI Assembly enhances it. And we started this out with Lego assembly. A conventional assembly process would take a 2D drawing or set of instructions, but with AR/AI Assembly, you can superimpose 3D instructions directly onto real-world objects using augmented reality. But assembling Legos isn't as easy as you think. It's usually a large pile of parts and there are many components to it. But with the help of AI, an object recognition algorithm can easily identify and track these components in a matter of 0.01 seconds. Object recognition is an AI algorithm that can help a machine understand what the things are in the physical world. This information can be displayed back to the user in augmented reality. And to do this, we trained a custom object recognition algorithm where we generated and labeled a large label set of Lego pieces so that the AI algorithm can learn and recognize them when they see it again in the real world. With object recognition, we're also tracking each and every single object as the user is moving them around. And with this, we're able to give the users a step-by-step assembly instruction of which component to pick, where to pick it from, and where to place it. This is a video of someone assembling a Lego sculpture. And as you can see, they're not using a 2D instruction. They're actually using a 3D interactive instruction that changes dynamically as you progress through the assembly. This is another assembly, and you can see the hand stays fully engaged in the making process. There's no flipping pages, there's no searching for parts, there's no sorting. It's just hands-on, uninterrupted making process. And this is how augmented reality and artificial intelligence can help with hands-on assisted assembly. But what if you want more creative process and creative freedom? You don't want to be tied down to a set of instructions made by a machine telling you what exactly to do. Can this process kind of help you also in the design process? And we asked this question in this project called Active Bending in Mixed Reality to design and fabricate a reconfigurable modular bamboo structure. But designing this wasn't always easy. It takes a significant amount of effort because these modules have to bend into each other to create these complex structures. And digital modeling tools are helpful, but not very much. So this is what we can do with digital modeling tools. We can simulate how a bamboo would bend and create these simulations of these modules. And we can even come up with different configurations and thousands of iterations if wanted to create a representation of what the design might look like. However, if we were to use a 3D modeling tool, it's not always the most intuitive. You're often thinking about how you're going to orient and move these modules in the software because you're using a keyboard and a mouse. You often end up thinking more about how do you navigate this 3D modeling software instead of the actual design process itself. With a physical model, you can move things around, feel their position, adjust them naturally. But the drawback about a physical model is that you actually have to make the physical model. You can't skip that step. It takes time and also material to make the physical model, which is the other drawback. But in the digital model, you don't have that same kind of limitation. So what we want to do is combine the best of both worlds using augmented reality and gestural recognition. The idea is that we're tracking the user's hands as they're moving these bamboo modules so that they feel as if they're moving real-life, digital, physical bamboo modules. And the best part of this is that you can keep on adding modules as long as you keep wanting them, and you can visualize the design on site and make changes as needed. Once you're satisfied with the design, the mixed reality environment has a physics-integrated simulation tool that can predict the structure's bending behavior before the actual fabrication step. And with this setup, you can design something during the day and have it built by night. Active bending in mixed reality is not just about making something cool with technology. It's about changing technology so that it can adapt to the way that you're making things and designing with your hands. And yes, when you make things, you're already using your hands to adjust, move, change things. How can we combine human touch with machine precision together? And this is what we explore in this other project called Gesture Recognition for Feedback-Based Mixed Reality and Robotic Fabrication, which is a case study of the Unlock Tower done together with Professor Leslie Locke, Sasha Zivkovic, and Lawson Spencer right here at Cornell. The project actually entails a lot of parts to it. But one of the most important part is using a 6-axis robotic arm to cut a log in a specific pattern to stretch it out that forms the structural panels of the tower. And here, we specifically use gestural recognition to track how a user would touch a physical object. In this video, the user is wearing an AR headset and they can simply touch a log, and the system automatically maps it out. The user can also touch the log to set where they want to cut the log, and the robot automatically makes the cut. We're essentially using physical touch with real objects to communicate with the robot. Essentially, we're using human touch to communicate with robots. And this process can also be helpful in other fabrication processes. For example, as you move a component, you can get real-time visual feedback. The feedback could go red or green if you move closer or further away from the correct location. The placement of the jigs were crucial because we used threaded rods to connect all the logs and actually stretch the logs to form a structural panel of the tower. Gesture recognition for feedback-based mixed reality and robotic fabrication is an example of how we can communicate with machines in a natural way. It's about how we can blend human touch with machine feedback and machine precision. And there's no one right way to make things. What I've shared with you today is a spectrum of ways we can engage with AI and robotics. You can start with a more active role where you're hands-on making side-by-side with a robot, or you can take a more passive role where you're actually maybe just describing the robot what you want and the robot builds it for you. The takeaway is the balance between automation and collaboration. Because at the end of the day, artificial intelligence can accelerate a lot of things. But creativity isn't just about moving from point A to point B. It's about the process. It's about the exploration. It's about the joy of bringing something new to the world. So whether it's designing, making, writing, or building, it's not only about what AI can do, it's how you can collaborate with AI to bring something wonderful into this world. Thank you.